is the study guide for the Chapter 10 test, and we're on rhombuses. So we're going to white out the bottom and look at the rhombuses. The formula for every rhombus is 1/2 diagonal 1 times diagonal 2. Area equal 1/2 times diagonal 1 times diagonal 2. So we get area equal. We know that the diagonals of a parallelogram bisect each other. A rhombus is a parallelogram, so the diagonals bisect each other. So one diagonal is 5 plus 5, which is 10, and the other diagonal is 12 plus 12, which is 24. We multiply. Half of 24 is 12 times 10 is 120. Any questions on number 13? Okay. Number 14. I'll move all this out of the way so we can focus on the problem at hand. So problem number 14, we want to find the area. Area of a rhombus is 1/2 times diagonal 1 times diagonal 2. So we get area equal 1/2 times, and we don't know either diagonal, so we've got to find the diagonals. Well, we know that this is a rhombus, and we know that all four sides of a rhombus are equal. We know that the diagonals of a rhombus are perpendicular and bisect each other, and each diagonal bisects a pair of opposite angles. So if that 60-degree angle was bisected, then that's going to be 30 and 30 and 30 and 30, and so we have four congruent 30, 60, 90 triangles. We're just going to extract one of those to focus on it. This is 8, which was the side. This is 60 degrees. This is the bisected 60, which is 30. We're going to call x half of one diagonal and y is half of the other diagonal. So we have a 30, 60, 90 triangle. We're going to write the formulas. Hypotenuse equals short leg times 2, and long leg is equal to short leg times the square root of 3. What we know is the hypotenuse 8, so hypotenuse 8 equals short leg, which is the x times 2. Short leg is opposite the 30. So now we're going to undo multiplication by division, and we get x is equal to 4. So this little piece is 4, so that little piece is 4, so that whole diagonal is 8. Long leg, which is y, is equal to short leg, which we just found out was 4, times the square root of 3. And so this would be 4 square root of 3, which is half of that diagonal, which means the diagonal that that's half of is double that, which would be 8 square root 3. So now we can solve. Half of 8 is 4 times 8 is 32 of those little square root 3's. Any questions on number 14? Okay. Number 15. Number 15, we have a rhombus. We know that the diagonals of a rhombus are perpendicular. So if we extract this right triangle, we have 26 and 10, and we'll call y half of the one diagonal. Now we know the diagonals bisect each other, so if this is 10, then this is 10, so we do have one of our diagonals. So the area is 1/2 times diagonal 1 times diagonal 2. So area is 1/2 times diagonal 1, which is 10, and 10, which is 20, and it was the other diagonal we didn't know. In this right triangle, we have two sides, and we're looking for the third side, so we use the Pythagorean theorem. A squared plus b squared equals c squared, where the side across from the right angle is the hypotenuse c. So we put the hypotenuse c squared is equal to one of the legs, 10 squared, plus the other leg, which we don't know, we called it y squared. We're going to do the exponents. 26 squared is 676 is equal to 10 squared, which is 100 plus y squared. It's time to undo. We're going to undo addition first by subtraction. We'll get 576 is equal to y squared. We're going to undo the square with the square root. What times itself is 526? 24. So 24 is this little piece, which is half of this diagonal. So the whole diagonal is 48. So we found the diagonal, so now we can find the area. Area is half of 20, which is 10 times 48, which is 480. Any questions on the rhombuses? Okay. Regular polygons. I'm going to shift that up. The area formula is 1/2 apothem times perimeter. Again, you may recall that on the test, I'm not going to give you the formulas. You will have to have those memorized. Now, on most standardized testing, there are some formulas given. Usually, the formula for every square and perimeter square are not given. Other formulas may be given to you, depending on the level of the standardized testing. Okay, so this first picture is a regular quadrilateral, which is a square, and a square, all of the angles are 90. All the sides are equal. We know that a radius bisects an interior angle, so it cuts a 90 in half, so that's 45. So we have a 45, 45, 90 triangle. We know that the apothem bisects the side because of the isosceles triangle theorem. So half of 4 is 2, so that's 2 and 2. We know that in a 45, 45, 90 triangle, the legs are equal. So if that bottom leg is 2, then the apothem is 2. In a 45, 45, 90, hypotenuse is equal to leg times the square root of 2. So the which is the hypotenuse is equal to a leg 2 times square root 2. So apothem is 2. Radius is 2 square root 2. We got that from the 45, 45, 90 triangle rules. I'll just go ahead and pull all that out in case we missed it maybe using the formulas. Since this is a review. The apothem bisects the side, so this is 2 and 2. So we could extract that right triangle. It's a 45, 45, 90. It's going to make me work for it. This little piece is 2. This is the apothem. This is the radius. In a 45, 45, 90 triangle, the legs are equal, and the length of the hypotenuse is equal to the length of a leg times the square root of 2. So if the bottom leg is 2, then the other leg, which is the apothem, is 2. So we get 2 for the apothem. The hypotenuse, which is the radius, is equal to a leg, which is 2 times the square root of 2. So the radius is 2 square root 2. To find the perimeter is 4 times the length of a side, and the length of a side was 4, and 4 times 4 is 16, so the perimeter is 16. Now, we could use 1/2 apothem times perimeter for area of a square, but we are familiar already with side square, so we'll just take side, which is 4 squared is 16 for the area of the square. Any questions on 16 to 19? okay? We're just going to kind of wipe it out and focus on the regular polygon that's a triangle. That poly was gone, wasn't it? We just whited it out. Anyway, all right. So if it's a regular triangle, that means that it is both equilateral and equiangular. Each angle of an equiangular triangle is 60 degrees. So this is 60 and this is 60. The apothem bisects a side. So this is 3 and this is 3. The radius bisects an interior angle. So if the interior angles were 60, then that's half of that 30, which makes that 60. So I'm going to extract that so we can see it better. After that little run of information, oops, I erased over whiteout. I'm sorry. Let me clean up here. I got a spot there where things don't write straight. I got a little bad spot on my board, I guess. See if I can make this look good. So we've got something like this. See that spot? We've got a 30, 60, 90 triangle. This little piece is 3. This is the radius, and this is the apothem. Now, the thing we know is the long leg. We're going to use our 30, 60, 90 triangles. Long leg equals short leg times the square root of 3. And hypotenuse is equal to short leg times 2. What we know again is the long leg, so long leg 3 equals short leg, which is the apothem. I'm going to go ahead and put A for apothem. So let me clean up. I forgot again. I can remember the math. I just can't remember not to erase over whiteout. But anyway, so the long leg 3 is equal to the short leg, which is the apothem times the square root of 3. So we're going to solve for A, the apothem. So we're going to undo multiplication by division. I just probably messed up again. And so we have that the apothem is equal to 3 over the square root of 3. But you can't have a radical in the denominator, so we're going to rationalize the denominator. We get 3 square root 3 over 3. The 3 is reduced to a 1, and so we just have square root 3. So the apothem is square root 3. The radius is the hypotenuse, so we use our other formula. Hypotenuse equals short leg times 2. So hypotenuse, which is the radius, equals short leg, which is square root 3 times 2. So the radius is 2 square root 3. The perimeter is the distance around. There's 3 sides. They're all 6 apiece, so the perimeter is 18. Now, for a triangle, use 1/2 base times height, and we don't even have the whole height drawn, so we're not going to resort to the normal formula for area of a triangle. So we're going to use the regular polygon formula, which is 1/2 apothem times perimeter. So we're going to take area as 1/2 times the apothem, which is square root 3, times the perimeter, which is 18. And so we're going to get area equal half of 18, which is 9 square root 3. Now, there's a shortcut for equilateral triangles that I keep mentioning, it is half of what a side is. Half of 6 is 3 squared, is 9 square root 3. Half of a side squared, square roots of 3. Half a side square, square roots of 3. You could have also used Heron's formula, which is a formula that you can use to find the area of a triangle if you know all the sides. But this is the regular polygon section, so it was nice to use the regular polygon formula, 1/2 apothem times perimeter. Okay? And so our last regular polygon is a regular hexagon. Now it's a little bit more challenging. We do know that each side, we do know that if it's I'm going to have to orient here. That was about 8 inches off of where I wrote. Okay, here we go again. The in a regular polygon, all of the sides and angles are equal. So if one side is 8, the rest of the sides are 8. The bottom was 8. Still is 8, I guess. The bottom is 8. We know that the apothem bisects a side, so that's 4 and 4. We know that the radius bisects an interior angle, but we don't know an interior angle yet. So we're going to use the formula for each interior angle of a regular convex polygon, and that formula is the number of sides minus 2 times 180 degrees divided by the number of sides. If we plug in 6 for hexagon, 6 sides, we're going to have 6 minus 2 times 180 degrees divided by the number of sides 6. So we would have 4, 6 minus 2 is 4 times 180 degrees divided by 6, which would give us 720 degrees divided by 6. So each interior angle of a regular convex hexagon is 120 degrees. Now we know that a radius bisects an interior angle, and half of 120 is 60, so that's a 60-degree angle right there. So we're going to extract that right triangle. We've got the apothem, we've got the radius. This angle is 60, this angle is 30, and the short leg is 4. So we're going to use our 30, 60, 90 triangles formulas. Hypotenuse equals short leg times 2, and long leg is equal to short leg times the square root of 3. Now what we know is the short leg 4, so we can plug it in there and there. So the hypotenuse, which is the radius, is equal to the short leg, which is 4 times 2, so the radius is 8. The apothem, which is the long leg, is equal to the short leg, which is 4 times the square root of 3. So the apothem is 4 square roots of 3. So apothem, 4 square root 3. Radius, 8. Perimeter. The perimeters, the distance around, are the sum of the sides. There's 6 sides at 8 apiece, so the perimeter is 48. Area. Area is 1/2 apothem times perimeter. So I'm going to erase this so we can see that. So we're going to have area equal 1/2 times the apothem, which is 8, times the perimeter, which is 48. And so we get area equal, half of 8 is 4. 4 times 48, 160, 32, 192. So the area is 192. Any questions on the regular polygons? Now, if you had a pentagon, the interior angle would be 108. The angle in that right triangle would be 54, and you'd have to use a sine, cosine, tangent ratios to find your apothem and radius. So don't forget you may have to use some trig functions to solve with also, depending on which type of polygon I give you. Okay, that brings us to area and circumference of a circle. Area and circumference of a circle, and then the areas of sectors and the area of the shade. So we're going to start here with the first example. We're going to get rid of our sector formulas because we don't need those for it. We want the area and circumference. So the formula for area of a circle is pi times the radius squared. Pi is 3.14. So we have 3.14 times radius squared. The radius is half the distance across the circle, 4 centimeters. We're going to do the exponent first. It distributes. And so we're going to have 3.14 times 4 squared is 16 centimeters squared. Now we multiply. 16 pi is 50.24. So we get 50.24 square centimeters. So we got that. The circumference is 2 times pi times the radius. So the circumference is 2 times pi, which is 3.14, times the radius, which is 4 centimeters. So we're going to multiply. We multiply the numbers and we multiply the names and we get a new name. 4 times 2 is 8. 8 times pi is 25.12. And the name tags on 25.12 centimeters. So the area is 50.24 square centimeters. The perimeter is 25.12 centimeters. Any questions on 28 and 29? Okay. Second circle. We want to find the area. I'm just going to string it across the whole board here. Area is pi times radius squared. So we have pi, which is 3.14. Times the radius, which is 6 inches, quantity square. And so we're going to have 3.14 times. We distribute the exponent onto the multiplication. 6 squared is 36 inches square. Now we're going to multiply. I'm going to put it down here. 36 pi is 100 and... I forgot. I'm forgetting my pi stuff. It's hard to forget pi, but I am this time. Times 3.14. Used to have all these memorized. It left me somewhere. 113.04. There we go. 113.04. 113.04. Need to remember that. 113.04 square inches. But we didn't want the answer in square inches. We wanted the answer in square feet. So we're going to multiply such that we lose the name square inches and we gain the name square feet. The larger one is feet, so we put a 1. It takes 12 of the inches to make a foot. We're not dealing with inches and feet. We're dealing with square inches and square feet, and so we square the conversions. 1 squared is 1, 12 squared is 144, so that's the real numbers we're dealing with. The name square inches cancels, and we're going to gain the name square feet. So we're going to have 113.04 on top. I'll highlight it. Square feet is the new name. 144 on bottom. So our answer is 113.4 divided by 144. Let's do that. Divide 144.785 square feet. Okay. Now we're going to find the circumference. I'm going to wide out the area and hope I don't make any mistakes so that it won't come running back through when I erase. Circumference is 2 times pi times radius. So circumference is 2 times 3.14 times the radius, which is 6 inches. So we're going to multiply. 2 times 6 is 12. 12 pi is 37.68. That's what hit me. 37.68, a better check. Pi, 12 times pi. There we go. It's coming back. 37.68. So we're going to have 37.68 inches. But we didn't want the answer in inches. We wanted the answer in feet. So we're going to multiply such that we lose the name inches and gain the name feet. There's more feet. It's the bigger, so we put 1. There's not more feet. Feet's larger, so we put 1. How many inches are in a foot? 12. We are talking about feet and inches, so we leave it 1 and 12. The name inches cancels. So we're going to have 37.68 on top. $12 on bottom, and the new name feet. So we're going to do 37.68 divide 12. Which takes us back to pi, 3.14. So the answer for to circumference is 3.14 feet. Any questions on 30 and 31? Okay. That brings us to the last picture. I'm going to erase this up here because we're going to be dealing now with the formulas at the bottom. Area of a sector and the area of the shaded region. If we want the area of the sector, it's like that whole slice here. It's like getting a whole slice of pizza. A sector is a region bounded by 2 radii and an arc. It's a part of a circle. It's not a part of a circle. It's like a slice of pizza out of the circle. The area of the sector, it's a fraction of the circumference. Here's our formula. The fraction is arc over 360. So we put the arc 60 over 360 times pi times the radius square. It's a fraction of the area. Arc over 360 times pi times radius square. So we're just going to multiply all that, and that's it. 60 divide 360 times. $60 divide 360 times pi times the radius of 6 square, 18.84. So the area of the sector is 18.84. And we didn't include a unit of measure there. All right. Now, we want the area of the shaded region, and the area of the shaded region is that whole sector. That's what we just found, minus the area of the triangle. So we need to think about the area of the triangle. Now, I'm going to wiggle this, and we're just going to start over. We're just going to treat this like we hadn't already found the area of the sector, and we didn't know what it was. And we're going to think about how to get the area of that shaded region. Now, that shaded region is the whole sector minus that triangle. So we're going to take the sector minus the triangle. There, the area of the sector is arc over 360 times pi times radius square. Take away the area of the circle, which is 1/2 base times height. Okay? So, we're going to start plugging into this formula. Area is equal to arc measure 60 over 360 times pi, which is 3.14, times the radius, which is 6 square. There's the area of the sector, minus the triangle, which is 1/2 times its base, which we don't know, times its height, which we don't know. So we've got to find the base and height. So we need to analyze that triangle. Now, I need to make this bigger. If that arc is 60, then this angle's 60. The arc is out here, okay? The arc is 60. I kind of set it on its bottom. The bottom being that edge that touches that shade, okay? So if the arc is 60, the angle's 60. These are radii, so they're both 6. If we draw an apothem, which is also an altitude, we're in an isosceles triangle because they're both radii, so it is perpendicular to the base and bisects the base. So that green thing is the apothem of an inscribed polygon, if it was an inscribed polygon. I shouldn't call it that because we don't have an inscribed polygon. It's the altitude of this it's the altitude of this triangle. We know the triangle is isosceles because two of its sides are radii, so they're both equal. So that is the bisector of the vertex angle. The bisector of the vertex angle of an isosceles triangle is perpendicular to the base at its midpoint. So what we have here are 30, 60, 90 triangles. Now, If I take one of those, what I know is the hypotenuse. I'm going to call this x, and I'm going to call this our height. Now, x is half of a side. We're going to use our 30, 60, 90 triangle formulas to solve. We know that long leg is equal to short leg times the square root of 3, and hypotenuse is equal to short leg times 2 in a 30, 60, 90. What we know is the hypotenuse 6. So hypotenuse 6 equals short leg, which is opposite to 30, which we called x, times 2. We undo multiplication by division, and we get x equal 3. Now, that 3 we got for x is half of a side, so the whole side is 6. So the base of our triangle is 6. The height is the long leg. We're going to put 3 in place of short leg to get long leg. So we're going to get long leg, which is the height, is equal to the short leg 3 times the square root of 3. And so the height is 3 square root 3. So we have all of the stuff we need to find the area of that shaded region. So we're going to do the 60 divided 360 times pi times radius square. It's what the area of the sector was, which is the 1884. Minus the area of the triangle. Half of 6 is 3 times 3 is 9 square root 3. And so there's the area of the shaded region. Any questions on the Chapter 10 study guide? So there will be a homework sheet like this and a test like this. Hope you do well.